Hello class, this is a video tutorial on the integration of trigonometric functions. In this video we're going to look at some indefinite integrals and some definite integrals. So let's begin. Although we know the general derivatives of trig functions as shown here, the functions that we're only going to be looking at integrating involving u equals ax plus b as shown as follows. So by this we mean we're not going to see any functions, any integrations of sine x or sine of x squared dx, as this does not follow any that form I've circled there. Okay, so let's begin. So sec squared of sec squared 5x dx. Well, sec squared here becomes tan. So let's begin there. It becomes tan 5x. It's always being divided by the coefficient of x there. So it's going to be 1/5 tan 5x. It's always plus c. With the integration that has a factor in front of the function, we can factor that out like so, making our integration slightly easier. This becomes -4 of, well, the integration of sine 2x. Integration of sine is cosine. Sorry, it's going to be negative cosine 2x. It's once again always dividing by that coefficient there, so half. Let's simplify the following. -4 times -1/2 is just +2 cosine of 2x. And never forgetting, at the end of an indefinite integral, it's just always plus c. This last example, very straightforward. We have cosine. The integral of cosine is just sine 3x dx. And once again, always dividing out by the coefficient shown here. And lastly, always adding that plus c at the end of an indefinite integral. So these are indefinite integrals. Let's move into our definite integrals here. Before I begin, because we're going to be substituting values of pi, we're going to draw out our exact ratios. Oops, sorry, to make this a lot larger. We have pi on 4, 1 √2. For this case, you don't have to draw them because I'm actually going to be erasing these at the end. This is just a reference for me to use as we, whoops, that's the wrong way around, pi on 6, pi on 3, √3, 1, 2. It's only because we're going to be utilizing these as we go about these substitutions. So let's get to it. First, let's integrate cosine of half x. The integral of cos is just sine half x. But if we're going to divide 1 on 1/2, 1 divided by 1/2 is 2. Oops. 2, and we're going to be integrating this, substituting pi from pi on 2. So let's substitute that. I'm going to take the factor of 2 on the outside. So it's 2 times everything. I'm going to substitute now the value. So it's going to be sine pi on 2 minus sine half of pi on 2 is pi on 4. Sine of 90, or sine of pi on 2, that's just 1, minus sine pi on 4 is 1 on √2. It's going to be 1 on √2. let's simplify this fraction here. I actually know this as 1 minus 2 on root 2. Oh, sorry. Root 2 on 2. So when we expand this, this becomes 2 minus root 2. And if you haven't known yet, because this is an integration, this is an area under the curve, so 2 minus root 2 units squared. Okay, let's move on to the next question. Move these out of the way. Leave them in sight because we'll be using them in a moment. So the integral of sec squared x, that's a very straightforward one. The integral of sec squared is just tan x from 0 to pi on 3. Okay, let's substitute these in now. This becomes tan pi on 3 minus tan of 0. Tan pi on 3 here is root 3 on 1. So this is just root 3. Tan of 0, you can think of this as sine 0 on cosine 0. Well, sine 0 is just 0. 0 over anything is just 0. So this is 3 minus 0. This becomes root 3 unit squared. One last example here. When it comes to the integration of two separate of integrals, only when it's subtracting or addition, so if this was addition, the following can be true. It's just integrating each one individually. So the integral of sine x is going to be negative 2 cosine x minus the integral of sine 2x is going to be negative half cosine 2x from, oops, oh, I deleted a number here. I believe that was going to be from 0. Yep, took a look at my notes. There we go. So it's from 0 to pi. Okay. So now let's integrate these values. Here we go. So let's substitute these values. Oh, actually, before I do that, let's clean this up. 0. These two negatives will become a positive. So I'm going to put the positive in the front. It's going to be half positive cosine 2x minus 2 cosine of x. Okay, and then we're going to substitute now pi and 0. Let's do one substitution first. Here's my first substitution, substituting pi. So half cosine of 2 pi minus 2 cosine of pi minus half cosine. If I substitute 0 into here, it'll just be cosine of 0 minus 2 cosine of 0. Let's evaluate each one as we go. Cosine of 2 pi is 1 times half is just half. Cosine of pi is negative 1. So that there is negative 1. Negative 1 times negative 2 is positive 2. Let's evaluate this one now. Cosine of 0 is 1. So 1 times half is half. Minus cosine of 0 is 1 times negative 2 is, well, 1 times negative 2 is negative 2. 2.5, that's 5 on 2. Minus half minus 2. So 2 minus half is 1.5, so that's going to be negative 3 on 2. Well, that's very straightforward. These two negatives become a plus, so this becomes 8 on 2, which is just 4 unit squared. Now we can get rid of these. There's that 0, by the way, that I deleted earlier. But hopefully that gave you an insight into integrating trigonometric functions, both indefinite integrals and substituting them for definite integrals. See you in the next video. Best of luck.